Today, we will take a look at integral. So we have the following relation between them. So when both of them are related to each other, inverse functions. So if you remember the meaning of a derivative, the, the simplest definition of a derivative is, who will tell me the simplest definition? What is the meaning of a derivative? Tell me.
The
Slope.
slope of the
Yes,
curve, of a slope of
wonderful,
a curve.
wonderful. It is a slope of a tangent line at the given point, of course. Slope of a tangent line or slope of a curve, you are right. So if you remember the first introduction lesson, calculus has two main goals. Calculus deals with two problems. One of them is slope of a curve. The second one, do you remember the second one? Second one is area,
The
sorry,
area. The
area
area under the curve.
under a curve. So screen, yeah, this one. Do you see the graph there now? This one?
Yes.
Yes.
Okay. So the problem is
Yes.
finding the area under a curve. Now, let us start with this one. So this is our mission. How can I find the area under this curve? Our curve is, by the way, x squared, as you can see. So we have the following method. Remember, if you don't know the total area, divide that area into some well-known figures. These figures mostly triangles and rectangles, but rectangles are better than triangles. So we will divide this area under a curve, that area, into small pieces. And that pieces will be a rectangle. But we have two options. You may use lower rectangles, like this one. 1, 2, 3, 4, 5. And in fact, at point 0, we have one more. You cannot see that one. We have these rectangles. If you look at the total area, it's given here lower, 16.3. But the original area is, in fact, 21.3. Yes, it's a really good approximation, 16.3. But it is smaller than the original area, smaller than 21, not the exact one. Okay. We have the second option. If you want, you may use the upper rectangles like that. 1, 2, 3, 4, 5, 6 rectangles. The area will be 26. It is greater than our original area. So we have a problem. Yes, our original area will be between the lower rectangles and upper rectangles. 21 is between 16 and 26. But I need a better approximation. So how can I get better approximation? Remember, if you have more rectangles, look at this. Now we have 11 rectangles. The area becomes 18. Very close to 21. It's not given the exact area, but very close to the exact area. Look at this. If we have more rectangles, now we have 30 rectangles. The area is 20.28. Really close to original area. If you look at the upper rectangles, 22.41, it's okay. Now the problem is this. If we send the number of rectangles to infinity, I mean, number of rectangle goes to infinity, 38, 40, 100, blah, blah, blah. It goes up to infinity of x here. Then there will be dx. We are calling dx differential, and you will remember this dx. It comes from here. Y prime is equal to dy over dx. So this dx and that dx is the same. So dx is differential. We are calling this differential. It tells you the variable with respect to x. You will take the integral of f of x. And what will be the result? I will use capital F of x plus c. I will explain all of the things, don't worry. So this f of x is called antiderivative. Antiderivative. This is called constant of integration. And this is called differential. And this is called our function itself, f of x. That's it. So all of the integral calculations seems like that. So integral sign, there will be a function, there will be a differential. You will see the meaning of differential, why it's really important for us, dx. F of x is antiderivative. So what is the relation between f of x and capital F of x, antiderivative? You will see. Let me write the relation between them here. So if this is f of x, here we have capital F of x. Now this is the relation. When you take the integral, you will get this. When you take the derivative of capital F of x, you will get f of x. So integral is capital antiderivative. When you take the derivative of antiderivative, you will get function itself. So this part was the definition. Maybe that's it. So now the second part.
And the C stands for the 1, the 10, 11, and all the other numbers.
Yes, when you take the derivative of both of them, I mean, in fact, here I made a small mistake. So when you take the derivative of this one together, it will be 2x. Because the derivative of a constant number is 0. It will be 2x.
Yes.
Now,
Sir, I was going to ask you, what does dx stand for?
Bravo,
now,
Sanada.
Differential.
really good question. Now, let me give you one more example and you will understand why we need that one.
Okay.
So, calculate the integral and write the answer in simplest form. So, how can I find the integral? Step 1, if you have a sum here, you could write in this form. So let me write this again.
So
First
should we write the sum in front of the
5.
integral?
I will write 5 is a coefficient, x to power 4 times dx, plus I have 4, I will write in this way. So if you have a plus, like the differential, you may take the integral one by one. So it is 5. What's the integral?
Sir, I don't understand. Why did you put 5 in front and 4 after the integral?
In fact, I can write in this way. Let me write in this way. Okay, same. I can write 4 dx. Same.
I don't.
Okay. So, what's the integral of x to power 4? X to power 5 over 5. You know that. No need to write 4 plus 1 over 4 plus 1. No need to write plus c here. If you write plus c, let's say c1, there will be another c2. You will add them, you will write c. So no need to write for each one c1, c2, c3. At the end, just we will write 1c. It will be cubed. So you may write in this form, integral of 3 times x cubed dx, 5 times integral x to power negative 2 dx, plus 6 times integral x squared dx. So integral of x cubed is x to power 4 over 4. Integral of x to power negative 2 is negative 1 over negative 1. Why? Negative 2 plus 1 is negative 1. Because we are adding.
Yeah.
Plus times 6 x 3 over 3.
Not forget to write plus c. This is the integral. If you could simplify. Let me simplify this. 3 over 4 x to power 4 minus 5 x to power negative 1 plus 2 x cubed plus c. This is the integral.